Hello and Assalamu alaikum warahmatullahi ta'ala wabarakatuh and a very good morning to all of you here. My name is Mohammad Ilham bin Noor Farooq. My matrix number is 01DEE24F1024 and I'm from class DEE3A. Today I'm here to talk about environmental control strategies for coal-fired power plant. Let's dive in. Introduction and problem statement. A coal-fired power plant is a conventional thermal power station that generates electricity by burning coal as its primary fuel. The fundamental process involves converting the chemical energy stored in coal into electrical energy. Now, let's look at the problem statement and challenges I face as environmental officer. The challenges that I face every day is coal-fired power plant are essential for meeting electricity demand, but they possess significant environmental challenges that must be managed responsibly. Key environmental concerns are number one, air pollution, emission of harmful gases such as sulfur oxide and particulate matter from coal combustion. Number two, thermal pollution. Discharge of heated water into rivers and lakes, disrupting aquatic ecosystem. Number three, solid waste generation. Production of large volume of fly ash and bottom ash as byproduct. Number four, high resource consumption. Intensive use of water and energy throughout the plant's operation. So we've just talked about the challenges that we have faced. So these are some of the proposed environmental strategy that we have come up to go against those challenges. Number one, emission control with ESP and FGD. Electrostatic precipitator or ESP captures more than 99% of particle matter, ash, dust from flue gas using electrical forces. Flue gas desulfurization (FGD) removes sulfur dioxide by recreating flue gas with sorbent as limestone, preventing acid rain. Number two, ash recycling waste to resource. Convert solid waste such as fly ash, bottom ash into valuable materials. Application, cement production, constant additive, and road construction. Benefits, reduces landfill use and create a circular economy. Last but not least, cooling tower mitigating thermal pollution. Replace one true water system uses evaporation in a closed cycle to cool water for reuse. Benefit significantly reduces thermal discharge to water bodies, protecting aquatic life. Now we'll be looking into the block diagram of enhanced coal firepower power plant with the pollution control system. As we can see at the top of the chain, we have coal supply and then boiler or furnace. From there, we are dividing into three, which is the heat part, flue gas part, and the ash. Let's focus on the heat first. From heat to steam, and then the steam generates steam, and then it will move the turbine, and then from the turbine, it will generate electricity, then straight to the electric power grid. But the balance of the steam will be into the condenser, and then the condenser will change it to warm water. Warm water will be transferred to cooling tower, and then the cooling tower will transfer the cool water and recycle back to the condenser. Now flue gas, the ESP or electrostatic precipitator to the flue gas defluorizer (FGD) and then clean gas on stack. Last but not least, the ash, from the ash to the ash handling system to the ash recycle unit and sales for cons, cement and road. Now we'll be looking a comparison on electrostatic precipitator and fabric filter or baghouse. There are key features here which I've listed down. So we'll be looking based on that. Basic principle, ESP uses electrical charges to attract and collect dust particles on metal plates. Meanwhile, fabric filter uses physical filtration by forcing gases through the fabric filter bags that capture dust. Effectiveness, ESP has a high effectiveness of 99% but less effective on very fine particular or ash with high electrical resistivity. Fabric filter or baghouse, very high, 99.9% for all particular sizes, including submicron particles. Operational costs, ESP is a high initial capital cost, lower operating cost because less energy and no bag replacement. Meanwhile, fabric gas is a low initial capital cost but high operating cost because it requires energy for pressure drop and periodic bag replacement. Complexity, high complexity and sophisticated high voltage electrical system and mechanical wrappers sensitive to flue gas temperature and composition. Meanwhile, fabric filter, low complexity, simple mechanical concept, require robust back cleaning system, pulse check. Environmental impact: produce dry, collected fly ash, which is easier to handle and recycle. No waste from the device itself. Spent filter bag becomes solid waste. It requires disposal. Potential for chemical cleaning waste. Pressure drop: very low, minimal fan energy required. But for fabric gas, high, because require more fan to energy to push gas toward the fabric. Maintenance: ESP maintenance is a complex electrical system and wrapper, and fabric filter is a routine bag inspection and replacement. Now we'll be talking about SDG 7. What is SDG 7? Sustainable Development Goal 7. Ensure access to affordable and reliable, sustainable, and modern energy for all. The goal emphasizes the need for energy that is not only accessible but also clean and sustainable for a long term. Now, what do I mean by this is I'll be explaining through this table here. So we have the solution that we have just talked about and what it contributes: affordable energy, contribute to clean energy, and a long-term sustainable benefit. So first is ESP plus FTG. What it contributes to energy: reduce long-term health and environmental costs, avoiding future economic penalty. To clean energy: direct clean the energy process by removing 99% or more of particle and more than 90% of sulfur oxide, preventing acid rain and smog. Long-term sustainable benefit: protects public health and ecosystem, ensuring societal sustainability and reducing the economical burden of pollution-related disease. Ash recycling turns waste into revenue, selling ash for cement, offsetting operational costs, and stabilizing energy price. Eliminates landfill waste and reduce the need of virgin material in construction, minimizing quarrying, and it's also associated with pollution. In terms of long-term sustainability, promotes a circular economy, conserving natural resources and providing a sustainable model for waste management. Cooling tower prefer cost environmentally finds and protect fishes, a vital food for economy source and communities. Prevent thermal pollution, protecting biodiversity in the river and the lakes. Ensure sustainable water is used and maintain the health aquatic system, which are critical for environmental balance. So in conclusion, the integration of a electrostatic precipitator (ESP) and flue gas desulfurization (FGD) effectively mitigates air pollution by removing particle and sulfur oxide. Coupled with ash recycling and cooling tower, we address a solid waste and a thermal pollution, creating a holistic environment management system. These strategies are not just operational upgrades, they are essential commitments to sustainability. They direct support SDG 7 by making energy production cleaner, reducing environmental health costs to make it more affordable, and conserving resource for long-term sustainability. By adopting this technology, we can ensure that coal-fired power generation meets today's energy demand while fulfilling our responsibility to protect the environment for future generations. Thank you, and that's all from me. I hope you guys enjoy this video, and please drop a like there. You're welcome.